Hi, here we're looking at a problem, three consecutive odd integers. The product of the second and the third minus the product of the first and the second is 52. What are they? So the question is, what do we mean by three consecutive odd integers? So let me put in the word odd here. Well, you know what an odd number is. 7, for instance. And another odd number would be 15. So we know what odd numbers are. So what we're looking for is consecutive odd integers. Well, again, starting with the number 7, the next consecutive odd integer would be the next odd integer in a row. So 7, the next one's 9, the next one after that is 11, 13, 15, and so forth, right? So we understand what consecutive odd integers are. Now, algebraically, the way that we handle this is we let the first odd integer in the series equal x, after which it always takes the form of x plus 2 for the next consecutive integer, then x plus 4, and so on, and so on. So if we want to express consecutive odd integers algebraically, x plus 2, x plus 4, x plus 6, and we use as many as we need. By the way, this works equally well for consecutive even integers. Okay, if that's the problem. In the situation of even integers, again, if you pick an integer, 6, it's an even number. If that's x, again, the next one would be x plus 2, or 8. The next one after that would be x plus 4, which is 10. So consecutive odd and even integers take the same form. If you're just dealing with consecutive integers, it would be x plus 1, and x plus 2. That's consecutive integers are one right after the other. All right, let's get back to the problem. So we're looking for three consecutive odd integers. Again, x plus 2, and x plus 4. The first one is x, the second one is x plus 2, and the third one, which I'll use t to represent that, is x plus 4. Okay, the product of the second and the third. Product meaning multiplication. Second is x plus 2. I'll just write that with an s up there. Third is x plus 4. So the product of the second and the third equals, oh sorry, not equals, minus the product of the first and the second. X is the first, x plus 2 is the second. The product of the first and the second equals 52. Is 52. What are the numbers? Well, we just have an algebraic equation here. In the first part of the problem, we have two binomials multiplied together. Remember, that's the FOIL method. First, outer, inner, last. So x times x is x squared. The outers are x times 4, which is plus 4x. The inners are 2 times x, which is plus 2x. And the last is 2 times 4, which is 8. In the second multiplication, we have minus x times x plus 2, which is minus x squared, and minus x times 2, which is minus 2x, equals 52. We just have a long equation to solve now. And the first thing we probably want to take care of is canceling out or simplifying anything we can on the left-hand side. Well, here's an x squared. Here's a minus x squared. They're going to cancel each other out beautifully. Here's a plus 2x and a minus 2x. Same thing. So really what we're left with is just 4x plus 8 equals 52. And by subtracting 8 from both sides and dividing by 4, we get 4x equals 44 and x equals 11. So if x is 11, that's our first one. The next consecutive integer would be x plus 2, which is 13, and the last one is 15. So 11, 13, and 15 are the three consecutive integers that satisfy this expression.